Okay, so yesterday we talked about some of the first steps for calculating a confidence interval for proportions. And today we're actually going to do it. We are going to go start to finish in our calculation for this confidence interval. And in general, we follow a 4-step process to do this. First, we define the parameter, so what we are estimating, and we select or we state our confidence level. Then we check the 3 conditions. Okay, because we can't perform our calculations, that's step 3, without knowing we've checked off those conditions. And then we interpret the confidence interval that we find using the context of the problem. And so just to review, our formula from yesterday is p hat plus or minus that critical value, which we learned is a z-score, times our standard deviation of p hat times 1 minus p hat over n. All right, and so example 1 says most people can roll their tongues, but many cannot. The ability to roll the tongue is genetically determined. Suppose we are interested in determining what proportion of students can roll their tongues. We test a simple random sample of 400 students in Hilliard City Schools and find that 317 can roll their tongues. Find a 95% confidence interval for the population proportion of students who can roll their tongues. That is what we are estimating. Okay, so that's our parameter. Proportion or percent, I don't care. And we are going to do this using a 95% confidence level. All right, our 3 conditions. We took a random sample. Right, we did an SRS of 400 students. All right, is our sample independent? Well, that depends. Is n less than 10% of the population? I would say yes. 400 is less than 10% of all HCSD students. Right? 400 is 10% of 4,000. There's definitely more than 4,000 students in Hilliard City Schools. And then, whoops, I skipped normal. I went out of order. Okay, to check normal, we have to figure out what our p hat value is. P hat is our sample percent, and that is 317 over 400. So 317 divided by 400 is 0.7925. So we will show that 0.7925 times 400, we know that already, will be 317, definitely greater than or equal to 10. And so then 0.7925 times 1, oh no, I'm sorry, you guys. It's n times p, so we should have done 400 times that percent. And n, 400 times 1 minus 0.7925 is 83. Both are greater than or equal to 10, so yes, it's normal. So here, if we want to correct this, it should say n times p, so 400 times 0.7925. All right, so now the calculation. So we start with our p hat value, so 0.7925. Now you may be wondering, do we have to go out to 4 decimal places? No, you don't. Remember, the AP test sticks to 2, but I like to stay as accurate as possible, and so for me, it's not harder to do 4 than it is to do 2, so that's why I go ahead and use all 4. Plus or minus our z-score. Well, that z-score is what we get from our calculator, right? So we need our negative z and our positive z, where we've got 95% in the middle. If 95% is in the middle, 0.025 and 0.025 are on the outsides. So in my calculator, because it's a charging calculator, I'm going to hit, 0.95, 0, 1, center, and I get plus or minus 1.959, so 1.96. So here, I'll scoot this over to here. Times the square root of p hat, 0.7925, times 1 minus p hat, over n was 400. Okay, so then I calculate that standard deviation in my calculator. Get 0.02, so 0.7925 plus or minus 1.96 times 0.02027, so maybe I'll say 0.03. So then I have 0.7925 plus or minus 1.96 times 0.0203 is 0.03978, 0.0398. Okay, and then I actually add and subtract. So 0.7925 minus 0.0398 is 0.7527, or 75.27%. And then if I add those, I get 0.82 or 8323. All right. So to interpret that, I will say we are 95% confident that the population proportion is between 75.27% and 83.23%. Now, I didn't specify the population proportion of what, because I did that already up here, right? And so as long as you've done it somewhere, you're good, right? So as long as you've defined that parameter up above, I'm okay if you're not specific in your interpretation. But if you don't do that up above at the very beginning, then you need to be very, very sure you do it in that last interpretation step. Okay, so there is example 1. This is where I would pause it. Try example 2, see how you do, but let's go ahead and try it. So a random sample of students who took the SAT college entrance exam twice found that 427 of the respondents had paid for coaching courses and that the remaining 2,733 had not. Construct and interpret a 99% confidence interval for the proportion of coaching among students who retake the SAT. So we are attempting to estimate the proportion or percent of coaching among all students who retake the SAT. Oops, sorry, guys. And we're going to do that using the 99% confidence level. Okay. Our 3 conditions. So we took a random sample. didn't really give us a simple random sample or anything like that, so we can just check that. Independent. Well, our sample size n was equal to 427 plus 2,733 because those were the two groups in our sample that they separated out. So in total, we have 3,160, which I would say is definitely less than 10% of all students who retake the SAT. Okay, so independent, check, normal. All right, so our p hat value, let's see here. We are looking for the proportion of people who had coaches, and 427 of our sample did. So 427 out of 3,160 is 0.1351. So we're going to do n, so 3,160 times 0.1351, which is 427, definitely greater than 10. And then n, 3,160 times 1 minus 0.1351, you maybe already are saying it's definitely going to work, is the other group, so 2733, definitely greater than or equal to 10. So it is normal. Okay, so now we perform our calculations. We already have p hat is 0.1351 plus or minus. Here our z-score. Well, we know we've got negative z and positive z and 0.99 in the middle. Now let's think about this. If we have 99% in the middle, then 1% is not included. Half of 1% is 0.5%, but we have to move that 2 over. So this will be 0.005. Okay. All right, so 99%. So we've got 0.005 that comes together to be 0.01, which adds with the 0.99 to make 100%. So when we put that in our calculator using inverse norm, some of us will put that 0.05. I'll put 99, 0, 1, center. Because I can do that, technically I don't have to calculate that 0.005, but I'm just double checking that everybody caught that. That gives me a critical value of plus or minus 2.5758 times our big square root, 0.1351 times 1 minus 0.1351 all over n, which was 3,160. Yikes, that's a lot of writing. Okay, so now I'm going to find that standard deviation, 0.1351 times 1 minus 0.1351 over 3,160 is 0.00608, so I might bump that up. So 0.1351 plus or minus 2.5. We're just going to shorten that critical value to 2.58 times 0.0061. So now when I multiply 2.58 times 0.0061, I get 0.0157. So when I subtract 0.1351 minus 0.0157, I get 0.1194. get 0.1508. All right, so now we interpret, and we say we are 99% confident that the population proportion is between 11.94% and 15.08%. All right, so hopefully that gives you 2 good examples and you feel ready to move on. You're doing 2 as well as your practice.